Okay, so our last area formula here is the area of a trapezoid. So a trapezoid is a quadrilateral, right? So it's another polygon with 4 sides. Now this one is different in that it only has one pair or 2 sides that are parallel. So a quadrilateral with exactly 2 parallel sides. Alright, so looks something like this. Okay, where we call the parallel sides, those are called bases. And so base, right, column base 1, base 2. Doesn't matter which one you call 1 or 2. And then the other 2 non-parallel sides are called legs. Right, and they are not necessarily going to be of the same length each. If they are, that's a special kind of trapezoid called an isosceles trapezoid, but it is not a requirement for those legs to be of equal length. Right, and the height of the trapezoid will be defined as from one of the corners here of the base dropping a perpendicular down to the other base. All right, so the area formula for this is going to be 1/2 the height, and then the sum of the bases. Base 1, I'll use the abbreviation B1 plus B2. Okay, so that would be our area formula for a trapezoid, right? Which is again a quadrilateral with exactly 2 parallel sides. Okay, let's just jump into some examples here. Okay, so let's look at our first example here. Okay, so here. So in this case, we do have a trapezoid where the legs are of equal length. Right, so this is again called a isosceles trapezoid. So one of the bases is 8, and then this other base is going to be 14. Okay, so I'd like to determine what the height is in order to use the formula here. Okay, so I'm going to start off, I'll draw the little perpendicular line segment here to signify the H. Right now, if I want to draw it on both sides because that's going to help me determine, right, what the height actually is going to be, right? So if I know base 1 is 8, so I know the distance from here to here is 8. Now, if these are, the legs are of a length 5, and so we have 2 right triangles here, and both have 2 congruent sides, right? 5, the hypotenuse, and one of the legs, which I've called H. So that means they are congruent, right? That is our hypotenuse leg congruency theorem for right triangles, which means that this line segment here has to be the same length. Because there are congruent triangles, which means if this is 8, the overall length is 14, that means that this little line segment needs to be 3. All right, and I need that to calculate the height, right? Because now I can use the Pythagorean theorem, right, where we have 25, or here, let me not skip some steps here. So here we'll have the hypotenuse, which is 5 squared, equals to the sum of the legs, each of them squared. All right, simplifying. So we get h squared, subtract 9 from both sides, equal to 16. So we get the height is equal to 4. All right, by taking the root of both sides. Okay, so now I have all the information that I need to calculate the area, right? So the area will be 1/2 the height, which I determined to be 4. And then the sum of the bases, 14 plus 8. Okay, so 14 plus 8 turns out to be, 622. So we get 44 units squared. All right, so that's how we would calculate the area for this problem here. All right, let's take a look at a different example here. Okay, so now let's say that I have a trapezoid that looks something like this. All right, so these sides are parallel, and this base up here is 9, and I'm also given that this leg is 12. And the only other pieces of information I know is that this is 30 degrees and this is 45 degrees. Okay. Okay, so again, I'll start off like I did the other one here, where we'll drop this little h here, and then this little h here. All right. Okay, so if this is 9, right, then I know that the value from here to here is also 9. All right, so, and I also know that if this is a 90-degree angle, this angle should also be 9. So here, that's going to be h as well. Okay. All right. Okay. And then I also know, since this is 30 degrees, this angle needs to be 60 degrees here. And I also know that this needs to be √3 times h. Okay. And again, here, all I'm using are properties of my 30-60 triangle and 45-45-90 triangle. Right, since that one is also 45 degrees. Okay, I think I have enough information here to calculate h. I'm going to use the 30-60-90 triangle and the Pythagorean theorem, right? So that means that 12 squared is going to be h squared plus h √3 squared. When I simplify this, we get 12 squared is 144, and here we have h squared squaring √3 gives me 3h squared. So we get 144 is equal to 4h squared. Okay, so now I'll divide both sides by 4. And we get, let's move it over here on this side, we get h squared. Let's see, this is divided by 4, 3, 36. Okay, and then we take the root of both sides, and we get my h to be 6. Okay. So now that means that base 1, I'll classify as 9. Base 2 is going to be all these three quantities, right? 9 root 3h, what I discovered was 6 root 3, plus 9, plus this other h here, which was 6. Okay, so base 2, simplifying here, we get 9 plus 6 is 15, plus 6 root 3. All right, and of course h was 6. All right, so now let's plug in all these values here. So area is 1/2 times 6 times base 1 was 9, and base 2, 15 plus 6 root 3. So simplifying this, 1/2 times 6 is 3. Combining like terms here, we get 24 plus 6 root 3. And the only other thing we can do here is we can distribute that 3. So that's what, 72 plus 18 root 3. And that is units squared. All right, so thank you.